So just a quick review, we're going to be able to tell if this ordered pair is a solution of a system of linear equations. So this is just a review, so we'll do it quickly. Remember that the first ordered pair is the x, the second is the y. And so when you substitute them in, for the y, you're going to put the 4 because, oh, that's the y. So 4 equals 3 times, instead of an x, so 4 equals 3 times the x is now a 1. Substitute it in, plus 1. So bring it down, 4 equals 3 times 1 is 3. Bring down the plus 1 here. And then we end up with 4 equaling 4. Well, that's true. But in order for the ordered pair to be a true solution to the system of linear equations, it needs to be true with both equations. It was true for this first one. We now need to try it for the second one. So instead of a y here, I can put the 4, because y is 4. Negative x would be a negative 1 plus 5. Just bring it down. Does 4 equal 4? Yes. So since it's true for both, we would put that yes, it is a solution. This ordered pair is a solution for this system of equations. Okay, but in this case, they gave us the ordered pair 1 and 4. How can we do it in reverse, if you will? How could we start off with the ordered equations and find an ordered pair that would be an answer or a solution? And that's really what we've been studying. We're trying to study is how can you solve a system of linear equations? Well, one way, there's multiple ways to do this, but one way is through graphing. That's what we're going to look at today, by graphing. Now, when we graph, solving a system of linear equations by graphing, the first step is to graph each equation. Well, that kind of makes sense, in the same coordinate plane. Second step is estimate the point that they intersect. And then third is check by substituting the answer into the original system. So let's do those 3 steps real quick. So the first step we want to do is to graph each equation in the same coordinate plane. So here's 2 equations. Let's go ahead and graph them in the same coordinate plane. I just rewrote them up here. The first one is y equals 2x plus 5. Now this is going to be simple to graph because it's in the slope-intercept form of y equals mx plus b. And because of that, we just have to locate the m, or the slope, and the b. Well, the m in this case is a negative 2, or if you like, a negative 2 over 1. The b is the 5. So that tells us where we're going to start. We're going to start this graph at 5. 1, 2, 3, 4, 5. And then we're going to do rise over run. We're going to go down 2 and over 1. 2 over 1. We could do it again, down 2 over 1. Notice that we're counting down from the last point we put in, over 1. Now we just draw a line through it. It's a pretty straight line. Okay. That gave us one of our points. But remember, we're trying to solve the system of linear equations. The system, and a system means more than one equation. So we've tried this one. Let's try the next one. Y equals 4x minus 1. Well, the m is 4, or if you want, 4 over 1. And the b is negative 1. So we'll start with the b at negative 1. And then we'll do the slope, or rise or run. We'll go up 1, 2, 3, 4 over 1. Up 4 over 1. Let's intersect that. Looks like they're intersecting right here, right? That's where the 2 lines are meeting. So if I were to see where that is on the coordinate plane, it looks like we go over 1, and we go up 1, 2, 3, or if we were to do rise over run, it'd be a 3 over 1. I'm sorry. We would write it as 3, it's 1 for the x, and 3 for the y. Because we went over 1 and up 3. So 1 and 3 is what we think is the right answer to both of these equations, the system. Let's see if it is the solution, though. So let's go back to that first question, and we'll write it in. So we're saying by graphing that we think 1 and 3 is the answer. Well, let's rewrite this and find out. Instead of a y, I can put a 3. A negative 2, but instead of an x, I'm going to place a 1. Okay, so 3 equals negative 2 plus 5. 3 equals 3. Actually, that's true. 3 does equal 3. And so we see that 1 and 3, this ordered pair, is a solution for this first one. But is it a solution for the system? Well, we have to now try it with the second equation. Let's do that real quick. So instead of a y, or again, we're writing a 3. 4 for the 4. Instead of an x, we're putting a 1. 3 equals 4 minus 1. 3 equals 4, take away 1 is 3. Oh, yeah, it came out the same. 3 equals 3. So since 1 and 3 come out with both of these as a solution, we know that 1 and 3 is the solution to the system of equations. All right. Let's do one more very quickly, and then I will have you guys try some on your own. We'll try number 3 here. Oh, let's do number 5. And number 5, the y is not already by itself. So the first thing you probably want to do is solve for y. So I'll do that really quick. I'll do it this time by doing a negative 2x. You don't have to solve for y every time. You can leave it in standard form where the x is first plus y equals a number. That's good if you want to use the intercept way of graphing. This way, this time I think I just want to get y by it. Okay, and then find the m and the b. So let's do the same thing on this. Let's get the y by itself. So if I were to take away a negative on both sides, you would have a negative 2y equal negative 3x plus 4. And then we divide by a negative 2. So we'd end up with y equals 3 over 2x minus 2. Okay, so let's graph these both and see if they have a common point that we can find. So the first one, start at plus 5. And then do rise over run. You're going to go down 2 over 1. Down 2 over 1. Okay, let's have these arrows on here. Let's do the second one here. Y equals 3x, or 3/2 x minus 2. So we'll start at negative 2. Then we'll rise 3 and we'll run 2. Oh, we might have already found it. Rise 3 over 2. Okay, so it looks to me like the intersection of x being 1, 2, and y being 1. So in order to find out, we have to substitute this into the original equation and see if it works out. Let's see if that 2 and 1 work out or not as a solution. So remember, the y is the 1 here. So it would be 1 equals 2, take away